Hey, everybody. Happy Asynchronous Wednesday. I know what you're supposed to say. We can't be happy we miss our teachers on Wednesday. I understand. Yeah, I understand. Yeah, I would miss me too. All right. Warm up time. You know the drill. Copy all the problems. Go try the problems. Come back and see how you did. Okay. Now, What is that all about? Problem. That is an order of operations problem. I want to remind you before you start, the very first thing you do in order of operations is parentheses. I put a P there, then I put these simple parentheses. They can be the fancy ones, right? They can be the big old brackets. But whatever you do all parentheses first. After parentheses, that's when you're going to do the exponents, right? Okay, and the analogy I use, like whoever takes cuts in front of everybody, whether you like them or not, the president's going to take cuts for everybody. That's the P. Now, who's after the president? Well, you were going to fight for grandma, right? Abuelita. You want grandma to be able to go in front of everybody. You'd even fight the president sometimes. Don't do that. You get in trouble. Secret Service, right? But you'd put everybody will allow grandma to go to the front of the line, right? All right. Now, after the exponents, and there's something else you're going to learn called square roots, right? We'll learn that later. But if you have all the parentheses done, any exponents there are done, after that, you have multiplying and dividing. But I always write dividing and multiplying, and I write it with the division symbol, the big X. The backslash means divide, right? And the big dot. And these are at the same level. They're like equals, right? They have equal values. So whichever one lined up first goes first. Now, the reason I always have the division first when I write it is to get you away from what's called PEMDAS. A lot of people learn how to do this using PEMDAS. So they always think the M comes before the D. Well, sometimes the D comes before the M. So that's why I don't teach it that way. I put the arrow here. Whichever one lines up first goes first. I always say that's the ladies first, right? And what's the most simple thing? Well, who's the most simple people in class? Yeah, the boys. The boys are the simplest. Don't argue, boys, right? You still laugh when I say gas giant. Jupiter's a gas giant, right? We're simple. I admit it, right? Girls are more nuanced, right? They can recognize more smells and more colors, they say, right? Yeah, that's the actual biological. They can. So the simplest things, they go last. That's subtracting and adding. And again, I do subtracting and adding because PEMDAS has the A before the S. And some kids think that it always comes before. Addition always comes before. No, for this level, whichever one lines up first. Whichever one lines up first goes first, right? But you're always going to have parentheses takes cuts, and multiplying and dividing will take cuts in front of any subtracting or adding, and exponents will take cuts in front of multiplying. Okay? All right. So you know that. Copy these down. I would rewrite these vertically because you got to change denominators on most of them. All right. And then this one here, I'll help you some more on the back, right? I want to have you see if you can figure out what the height is to this. If these triangles are similar, that means they're the same shape. Not all triangles are similar, but pretend like this is like the baby and this is the daddy, right? Right. So see if you can figure out how high you think this should be and how wide this should be. All right. I'll see you in a bit. Wow, that sure was a fast bit, right? All right, diamonds. What two numbers have a product of 56 and a sum of 15? 7 times 8, 7 plus 8, right? How about 39 and 16? 3 times 13 is 39, and 3 plus 13 is 16. 72 10,000ths and 17 hundredths, right? What's going to work there? This is going to be 8 hundredths plus 9 hundredths. Remember, when you add decimals, you got to line up those decimals, right? And then the decimal comes straight down. You add 8 plus 9 is 17, 0 plus 0, right? And then when you multiply, you pretend like there's no decimal there. I just go 9 times 8. That's 72. But in order to pretend this was an 8, I had to move the decimal over 2 spots to get it in front of that 8. And I had to move this one over 2 spots. That's a total of 4 spots in my problem. I have to go back 4 spots in my answer. 1, 2, 3, 4. What do we do here? I say fill in the egg carton. All right. All right. Big challenge on this one. There's a star next to that one. Could you figure that one out? 5 3/4 and 7. Anybody? 4 times 1 and 3/4. Okay. 4 times 1 is 4. 4 times 3/4, that's the same as 4 over 1 times 3 over 4, which is 12/4, which 4 goes into the top 3 times the bottom once. That's 3. 3 and 4 is 7. And 4 plus 1 3/4 is 5 3/4. Okay. If you didn't get that, that's okay. We haven't really learned how to multiply mixed numbers yet. Okay. Cool thing about this book, okay, there's a lot of things about this book I'm not too thrilled with, but one of the cool things is they teach you that generic rectangle, and that's a great way to multiply mixed numbers. We'll learn that later. Okay. So, challenge. Did I stump the whole class? If I stump the whole class, I get a point. You guys owe me a point. All right. On to the what are we doing first? Parentheses. I got one set there, a little set there, a little set inside a big set. I'll do this first. 2 to the 3rd power is not 6. It's 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. 1 to the 3rd power. That's 1 times 1 times 1. What is that? Did that fool you? It's not 3. It's 1. 1 to any power is going to be 1. So that ends up being a 7. Okay. And here I have 2 to the 3rd power. That's not 6. We figured out that's 8. So 8 and then parentheses 7. What do I do there? Remember, if there's a number next to parentheses and no operation in between, you're multiplying. So 8 times 7 is 56. 16 to the 2nd power. 16 times 16, everybody? 256. What's the difference between 256 and 56? This whole big block of parentheses ends up being 200. Now I'm going to subtract, and I got 3, and I got another set of parentheses. 24 backslash 4. That means 24 divided by 4, or 24 over 4. I'm writing the answer already. That equals 6. Same as 6 over 1. 4 goes into 24 6 times. Now 3 parentheses 5. That means 3 times 5. What's 3 times 5? 15. Now, am I going to subtract 200 minus 15, then multiply it by 6? No, I multiply before. So I have a subtracting, right? What's my problem now? I got 200 minus 15 times 6 plus this big, ugly, scary fraction. I don't even want to look at that. It looks so scary. Did I fool you? Anybody recognize it? That's not ugly, scary. That's your friend. Look at this. 3, x squared, y squared, z to the 6th power. This is the same thing over the same thing. And whenever you have the same thing on top as the bottom, that fraction simplifies to 1. Haha, scared you. You got scared for no reason. Psych. All right. 15 times 6. I got to do that multiply before I subtract or add. And 6 times 15 is 6 tens is 60, and 6 fives is 30. 60 and 30 is 90. So now I have 200 minus 90 plus 1. Is it 200 minus 91? No. I'm going in order from left to right. 200 minus 90 is 110. And 110 plus 1, 111. All right. Now, there's about 20 different things you got to do to that problem. If you didn't get the right answer, that is fine if you can find where you went wrong. If you solve these problems step by step like you should solve algebra problems, you can find out where all of your answers came from, right? Whoops. These 2 became the 7. This became the 8. All right, 16 squared became 256. That 200 came from 256 minus. 3 times 5, that became the 15, right? 24 divided by 4, that became the 6, right? 15 times 6, that became the 90. 200 minus 90 became the 110. I can trace all of my answers back, okay? When you do that, you can find out where you went wrong, which is cool because that's where you learn, okay? All right, let's roll. This is taking a long time. I've been talking too much. I have to get a common denominator. We're going with 30ths on here because 5 and 6 go into 30. I did 6 times 5, so I got a 1 times 5. I did 5 times 6, so I got a 4 times 6. Right? Don't put a 6/30 up there. 4 times 6. 24 minus 5 is 19/30. Okay? 9/16 plus 15/16. I don't have to get a common denominator, but I do have to simplify, huh? 8 goes into the top and bottom. 8 goes into 24 3 times. 8 goes into that. Okay, and that's still improper. Excuse me. All right. Scary sound during COVID, right? 3/2 is the same as 1 and 1/2. 7/8 minus 1/4. 4 goes into 8, huh? So let's change this to 2/4. 7/8 minus 2/4. 2/8, right? 7/8 minus 2/8 is 5/8. And 1/2 is the same as 4/8. So I'm going to say that's 9/8, which is improper. Use 8/8 to make one whole. So 9/8 is the same as 1 and 1/8. Okay, 1/2 is the same as 5/10. 5/10 minus 3/10 is 2/10. 19/20 minus 2/10. Let's change that to 20ths. Minus 4/20 equals 15/20. Can I simplify? I can. 5 goes into the top and bottom. This ends up being 3/4. Okay. Now I'm going to change this to thousandths by multiplying the top and the bottom by 10. I'm going to change the 10 to thousandths by multiplying the top and the bottom by 100. 1/10 is 100 thousandths. 100th equals 10 thousandths, and 1,000th is 1,000th, right? So I have 100 plus 10 plus 1 equals, coincidence, quinkydink. Quinkydink. I had a friend in high school who used to say quinkydink instead of coincidence. 111. Why is that a quinkydink? 111, 111. Whoa. All right, this problem. This is what's called proportions. If this triangle is similar to this, that means they have the same shape. Remember, not all triangles have the same shape. You can have a tall, pointy Christmas tree-like, and you can have an obtuse, right? Not all triangles have the same shape. But we're saying these two have the same shape. One's just bigger than the other. So what is H? Well, this is how you're going to do this, right? If they are similar, then they are proportional, right? They are proportional. So you can say 5 is to 15 like 4 is to W, right? This slant, I always call it the skateboard ramp side. In math, we call it the hypotenuse. Hypotenuse to hypotenuse, I would say ramp to ramp, is like base to base, is like height to height. Okay, so 5 is to 15, like 4 is to W, like 3 is to H. Okay, and that's just a ratio, right? 5 is to 15. 5 to 15 is like 3 to H. It's like 4 to W. 5 over 15 is like 3 over H. It's like 4 over W, right? Well, if 2 over 8 is equal to 1 over 4, then 8 over 2 will also be equal to 4 over 1. Okay, so 5 over 15 equals 3 over H. Well, 15 over 5 equals H over 3. Okay, so check this out. I can simplify 15 over 5. That's the same as 3 over 1. So this triangle is 3 times bigger. Okay, now when you get good at these, you're going to be able to say, okay, 5 goes into 15 3 times. So this is 3 times bigger. So 3 times 3 and 4 times 3. Okay. We're going to go ahead and write the ratios and say 3 over 1 is equal to h over 3. What did I do to the 1 to make it 3? I multiplied it by 3. So do 3 times 3. H must equal 9. Okay, now if you don't get this, don't freak out. I'm planting a seed. This is something you're going to have to do later. Okay, just follow along, listen, watch. Okay, this W, 3 over 1 is equal to, what is that W over 4? Well, again, it's like the magic 1, right? What did I do to make this a 4, right? I multiplied it by 4. Do the same thing on the top. And I go 3 times 4. So that is going to be a 12 up there. Okay. So this will be 9 and that will be 12. Okay. 9 and 12. All right. All right. Again, don't freak out. That's planting a seed. That's something you'll do later. And I just wanted to have you get a good look at it first. Okay. Sorry for the length of this warm up, but hey, it's on time today, huh? And you have sound. Woohoo! Cowbell. Woohoo! All right. They ring the cowbell at the end of the race. You're done with this race. Enjoy the rest of your day, everybody.